Alright folks, today we're going to talk about contour lines. We're just going to have a brief overview on these whiteboard, and then we're going to get to some satellite imagery. So contour lines, what are they? Why do we need them? Contour lines are these red squiggly lines which create a circle, and they're 10 meters apart. They have an increment of 10 meters. They can be spaced 20 to 50 meters at times if it's a much bigger mountain, say like Mount Everest, where if there's increments of 10 meters, they'll be much more squeezed into a smaller map, so they're spread it out more. Every time that a loop is self-enclosed like this, that's 10 meters. So if it's 1, 2, 3, then that's 3 loops, so that's going to be 30 meters. We'll have a look at some basic features and then we'll get into the satellite image. So over here we have two basic images, basic models, both 3D. One's kind of the figurative, what would see in a perfect world, and then one's what would see in the real world below. So we'll start with our figure up the top here. So this is just increasing circles from the inside out. So 1, 2, 3, 4, 5. So let's draw 5 circles. 1, 2, 3, 4, and 5. That would be closed off. So as we can see, it's pretty basic. Not many mountains like this exist in the real world because of how it all actually forms. But that's right, we'll just work with this for now because it gives us a good example. As we can see, each time the circle climbs up one, it goes another 10 meters. So if the outside is 0 meters for this example, that'd be 0, that'd be 10, that'd be 20, that'd be 30, and the top would be 40 meters above sea level. So that means between 0 meters, the outside, and the top, it's climbed plus 40 meters. Or it's lost 40 meters if you're going down. And you work out the gradient by the distance traveled, and that'll tell you how steep that hill is. In this case, the hill is the same every way. The lines are spaced apart equally, so the hill will be equal all the way around. Let's talk about some land features. So here we have a model of what the mountain probably would actually look like, and again later we'll get into satellite imagery. So some features just looking at this model, and then we'll look at the contour lines. This is the top, that's clearly the top. It's also known as the knoll, when the circle is self-contained within itself, and in the real world it's at the top here. We have spurs coming down each side, spur there and spur on that side, and we can tell this because it looks like a big finger coming down off the hill, or coming up down off the hill. We also know that it's a spur because the gradient's dropping off, the slope's dropping off each side of the spur as you're coming down. This here part would be called the ridge because it kind of stays nice and flat, and this would be the saddle. A saddle is a feature that's between two knolls. As you can see, there's a knoll up this side and there's a knoll up this side, and that's what we call the saddle that sits between two high points. Down here we have the gully, and a gully is where all the water would rush off because that's the depression in the side of the hill, and it's not going to come off the spur because it will run off the side of the spur down into the gully. So we know in the gully when we're walking and the hill comes up either side of us, whereas a spur, the hill drops off beside us. So gully, it comes up next to us, spur, it drops off next to us. It's also much more wet and damp in the gully and tends to be where bigger trees and bushes and undergrowth grows because there's more water through there. If I was to draw what this would look like with contour lines, in a very rough sense, it would look something like this. Again, it's a very rough sense, but you can see that there's two enclosed loops at the top, 1, 2, which form the knolls. We have two spurs on either side, 1, 2, where they look like the fingers that come off. We have a gully coming off here because it looks like a finger pointing up the hill, and that's where the water would run off. and would have the saddle that sits in between the two knolls saddle. So as you can see, this is a much less perfect and symmetrical contour lines than our little bullseye over here, but it's more so what we'd see in the real world. What we're going to do is going to get into some geography mapping and look at some satellite imagery of what would actually these look like in the real world.